The computer. From keyboards to VR. Hey everyone, and welcome back to our series on human-computer interaction. In our last lesson, we dove into the human side of the equation our brains, our memory, how we perceive things. Today, we're shifting our focus to the other half of this conversation, the computer. Lesson 2.2. The computer. Think of it like any good partnership. To understand the interaction, you need to know both players. So, what are the core components we interact with? It's way more than just the keyboard and screen. We're talking touchpads, speech recognition, 3D mice, and even force feedback. We break it all down into 3 simple categories. How we tell the computer things input, how the computer shows us things output, and everything in between. Let's get started. Text entry devices. First up, how do we get texts and commands into the machine? The most common method is, of course, the QWERTY keyboard. You know it. I know it. It's named after the first 6 letters on the top row. But is it the best? Well, some thought an alphabetic keyboard would be easier to learn, but studies show it doesn't really help, even for beginners. What about speed? Enter the Dvorak keyboard, designed to maximize typing efficiency by placing the most common letters under the strongest fingers. It's faster for trained users, but QWERTY's dominance is a tough habit to break. But what about when you're on the go? Chord keyboards have only a few keys. You press combinations to make letters. Fast, once learned, but can be tiring. Phone keypads use multi-tap or predictive text like T9. Handwriting recognition lets you write naturally with a stylus, but it faces challenges like interpreting different writing styles. And speech recognition, the dream of talking to our computers, is improving but still makes errors, making it best for specific commands rather than long documents. Positioning, pointing, and drawing. Okay, we've entered texts. Now, how do we point to and manipulate things on the screen? The king here is the mouse. It detects motion either mechanically with a ball or, more commonly, now optically with a light. This motion moves the cursor on your screen. But there are so many alternatives. Touchpads on laptops, you just stroke your finger. Trackballs like an upside-down mouse you spin with your palm. Joysticks, great for games and precise movements. Touchscreen's the most direct method. You touch what you want. The downside: your finger is a bit blunt, so it's not great for precise drawing. For more precision, we use a stylus on devices like tablets. And for the ultimate hands-free experience, iGuys systems let you control the computer just by looking at it. How cool is that? Display devices. Now let's talk about how the computer talks. Back to us. Displays. Almost all displays are made of tiny dots called pixels. Ever seen jagged edges on a diagonal line? Those are the jaggies. To fix this, we use anti-aliasing, which adds shaded pixels to blur the edges slightly, tricking your brain into seeing a smooth line. It works for text, too. The 2 main display technologies are 1. CRT, cathode ray tube. The big, heavy, old-school T. Bi-like monitor. It uses an electron gun to light up phosphors on the screen. 2. LCD liquid crystal display. The thin, flat panels in your laptop and phone, they're lighter, more efficient, and have mostly replaced CRTs. And displays go beyond our desks. We have large screens for lectures, situated displays in public places like airports, and even experimental digital paper that's flexible and holds an image without power. Beyond the desktop VR, sensors, and paper. This is where it gets really interesting. Computers are escaping the box and integrating into our world. In virtual reality, we need to move in 3D space. This requires 6 degrees of freedom, not just left, right, and up, down, but also the angles, pitch, yaw, and roll. We use special devices like 3D mice and VR caves for this. But be warned, slow graphics in VR can cause motion sickness. We also have physical controls and sensors. Haptic feedback adds a sense of touch, like the clicks you feel in a BMW Z-Drive controller. Sensors are everywhere, from the light that turns on when you open your car door to biosensors that measure your heart rate. Finally, let's not forget paper. Printing has evolved from dot matrix to high-resolution laser printers. Design matters. Two-seater fonts, like Times New Roman, are often easier to read in long paragraphs, while sans serif fonts, like Helvetica, can be clearer on screens. And with scanners and OCR optical character recognition, paper becomes an input device again, turning printed text back into digital data. Conclusion! So, as you can see, the computer is so much more than a simple box. It's a vast ecosystem of input devices, from keyboards to eye gaze, and output devices, from high-resolution screens to force feedback controllers. Understanding these technologies is the first step to designing interactions that are effective, efficient, and even enjoyable. That's it for Lesson 2.2. In the next video, we'll start putting these components together to talk about the interaction models that connect the human and the computer.